Dear students, welcome to Impulse Masterclass, a program designed for 10th class students. I am Kishore, senior faculty in mathematics with an experience of 27 years. At present, I am working with Impulse. Today, we are going to discuss trigonometric ratios for higher values. Let's have a look at this question. Find the value of sine of minus 420 degrees, cos of 390 degrees, plus cos of minus 660 degrees, sine of 330 degrees. Most of the students would confuse when theta value is greater than 360. In this class, we discuss how to find trigonometric ratios for higher values, that is when theta value is greater than 360 degrees. To solve the problem, we need to understand some trigonometric concepts. The first one is sine of minus theta is minus sine theta, cos of minus theta is plus cos theta, and sine of n pi by 2 plus or minus theta is equal to plus or minus sine theta or plus or minus cos theta. If n is even, plus or minus sine theta. If n is odd, plus or minus cos theta. Let us discuss one by one. Let us understand how sine of minus theta is minus sine theta. To understand this, let us look at this diagram. We already know that sine theta for this diagram is y by under root x square plus y square. If you look at this diagram, for this point we discussed that sine theta, in the here place of theta we have minus theta, so here you need to put minus theta. For this point, theta is the corresponding angle here, so sine of minus theta is negative y by under root x square plus y square. This is equal to, if you take this minus common, but already y by under root x square plus y square is sine theta. So sine of minus theta is minus sine theta. We discuss this also through the same diagram. For this, cos theta is x by under root x square plus y square. And for this, cos of minus theta is x by under root x square plus y square. Here x by root of x square plus y square is cos theta, so we can put cos theta. Thus, cos of minus theta is cos theta. We proved this also. Now, let us understand what is the relation between theta and 90 minus theta in coordinate system. If we take a point P x comma y here, if I join these two, we got one angle theta here, which is making with x-axis. Similarly, if we draw an angle theta, which is making with y-axis, and join these 2 points, here the angle is theta. Let us find out the coordinates of this point, because from here to here angle is 90 minus theta. Here we do one thing. Let us rotate this angle like this. The new position of this angle will be here. So this length is same as this length. Here if I draw a perpendicular from here to here, this distance will be x and this distance will be y. If I rotate this like this y will come here, this is y, and this x is nothing but this is x. If you take this length, which is x, I wrote x here and height y in the second place. So for this angle theta, its corresponding point is here. Now we can predict the coordinates here. For this, if you observe from here to here, the distance whichever is y, that can be kept here, and the height, this height or this height are same. Since this height is x, we can write this also x, and this height can be kept here. Therefore, for 90 minus theta, its corresponding coordinates are y comma x. If you look at hypotenuse, this is root of x square plus y square. This is also root of x square plus y square, because this is a circle with center origin. This is radius, this is radius, so these distances are same. Using this method, let us find sin 90 minus theta and cos 90 minus theta here. For this triangle, we already discussed that sine theta is y by under root x square plus y square, and cos theta is x by under root x square plus y square. Now we discussed that if we rotate this like this, we get this diagram, and from here to here angle will be 90 minus theta. Just now we wrote that this point is y comma x. For theta, sin theta is y by under root of x square plus y square. So for 90 minus theta, sin will be x by under root x square plus y square. But x by under root x square plus y square is nothing but cos theta. Therefore, we can say that sin 90 minus theta is cos theta. Similarly, for cos theta, x by under root x square plus y square. For 90 minus theta cos, so cos 90 minus theta will be y by under root x square plus y square. But y by under root x square plus y square is sin theta. Therefore, cos 90 minus theta is sin theta. Now let us see this in second quadrant. This angle, if I take the same angle theta here, always we have to count from the initial position. This is always initial position. From here to here it is 90 plus theta. So the position of this point from the initial ray is 90 plus theta. Here the coordinates are just, if you take the image of this point on the circle with respect to y axis, you know that this y, this distance is same as this distance and height is same. This distance is y here and this height is x here. So this distance is same as this distance. Since this is y, here also this distance is also y, but negative direction. So this becomes minus y. Height is same, height is positive only. So x. In that way, we can write points here. And the angle from here to here, it is 90 plus theta. 90 plus theta. So sine 90 plus theta. If you write sine 90 plus theta, for 90 plus theta, sine value will be here x by under root x square plus y square. Now look at theta where x by root of x square plus y square is there. X by root of x square plus y square is there for cos theta. So this can be written as cos theta. Therefore, sine 90 plus theta is cos theta. Similarly, for 90 plus theta, see what happens to cos. Cos 90 plus theta. Cos 90 plus theta. Whenever cos is there, we look at this. So minus y by under root x square plus y square minus y by under root x square plus y square is here, which is nothing but sin theta. Therefore, cos 90 plus theta is minus sin theta. Now let us find this sin and cos values for 180 minus theta. From here to here it is 180. So I take theta here. Now from here to here it will be 180 minus theta. So the position here is 180 minus theta. Let us find the coordinates of this point first. This point is nothing but the image of this point. From here to here, distance is x. Therefore, from here to here, distance also must be x, but this is negative direction. So this here it is x, this is minus x, comma. The height here and here are same, it is y, so it is y. Now for the point for 180 minus theta, sine for 180 minus theta will be, its y coordinate is y, by under root x square plus y square. But y by under root x square plus y square is sine theta. Therefore, sine 180 minus theta is sine theta. Similarly, cos 180 minus theta. For 180 minus theta, cos value will be here minus x by root x square plus y square, minus x by root of x square plus y square is cos theta. Therefore, cos 180 minus theta is minus cos theta. Now let us find out the coordinates of this point for 180 plus theta. This point is nothing but image of this point. This is in second quadrant, minus x comma y. So in third quadrant, the image will be negative x comma negative y, minus x comma minus y, or the coordinates for this point. For this, sine, for this means for 180 plus theta, sine 180 plus theta is equal to, sine is always this coordinate we have to write, minus y by under root x square plus y square. But y by root of x square plus y square is sine theta. Before that we have minus sine theta. Therefore, sine 180 plus theta is minus sine theta. Similarly, we write cos 180 plus theta. For cos, we have to look at this coordinate, which is minus x by under root x square plus y square, minus x by under root x square plus y square is cos theta. Therefore, cos 180 plus theta is minus cos theta. This is minus cos theta. Now let us find the coordinates for 270 minus theta. 270 minus theta. From here to here it is 270 minus theta. You see this angle, same angle. I kept vertically opposite. Theta, theta. If you start from here, it is 270 minus theta. So for 270 minus theta, the coordinates will be the reflection of y comma x with respect to origin, exactly opposite to y comma x. This is in first quadrant, this is in third quadrant. So same coordinates with a negative sign will come, minus y comma minus x. For the point 270 minus theta, when angle is 270 minus theta, by looking at the coordinates we can say it's a sine value. Sine value is always second coordinate by under root x square plus y square. We know that x by root x square plus y square is cos theta. So sine 270 minus theta is minus cos theta. Similarly, cos 270 minus theta, cos value always we have to take the first coordinate, minus y by under root x square plus y square. We know that y by under root x square plus y square is sine theta. Before that we have minus, so it is minus sine theta. So cos 270 minus theta is minus sine theta. Let us see 270 plus theta. From here to here it is 270 plus theta, and 270 plus theta, the coordinates of this point are nothing but exactly the image of this point, minus y comma x. This is in second quadrant and this is in fourth quadrant. Y comma x we have to write in fourth quadrant, x is positive, x coordinate is positive, x coordinate is y comma minus x, y coordinate is negative. So sine 270 plus theta will be this coordinate, which is minus x by under root x square plus y square. You know that x by under root x square plus y square is cos theta. So sine 270 plus theta is minus cos theta. Minus cos theta. Similarly, cos 270 plus theta. For cos, we have to look at this coordinate, which is y by under root x square plus y square. You know that y by under root x square plus y square is sine theta. So cos 270 plus theta is sin theta. Most of the students solve problems by using these concepts, but there is a trick for this. Whenever you see 90 or 270 means 1 into pi by 2 or 3 into pi by 2, which is an odd number. So when an odd number comes here, sine becomes cos. When n is even, sine remains sine only. And before that we have plus or minus, that depends upon the total angle over here, in which quadrant it is present. Basing on the quadrant, we decide plus or minus. The same thing is true for cos or tan or for any trigonometric ratio. Let's come back to our original problem. The given problem is sine of minus 420 degrees cos 390 degrees plus cos of minus 660 degrees sine 330 degrees. We discussed that sine of minus theta is minus sine theta. So minus sine 420 degrees and this 390 degrees plus cos of minus theta is plus cos theta only. So cos 660 degrees into sine 330 degrees. Now let us use our discussion that 420 degrees can be written as 360 plus 60. Always use a quadrant angle here. 0 degrees, 90 degrees, 180 degrees, 270 degrees or 360 degrees are called quadrant angles. Use quadrant angle, nearest quadrant angle to this, and the nearest quadrant angle for 390 degrees is 360 plus 30 plus cos, this is 2 times 360, 720 minus 60, and sine 330 can be written as sine 360 minus 30. This is equal to, this is like sine 360 plus theta, which is sine theta only. In the place of theta we have 60 and before that we have minus sine 60 degrees. Cos 360 plus theta, cos 360 plus theta is cos theta. In the place of theta we have cos 30 degrees. So cos 30 degrees plus, we write this cos, let us write this in terms of n pi by 2. So 2 times into 360 is nothing but 4 into 90 minus 60 degrees into, this is like sine 360 minus theta, which is minus sine theta. So minus sine 30 degrees. Here minus sine 60 into cos 30 degrees plus 2 4s are 8. Cos 8 times 8 is an even number. When even multiple of pi by 2 comes, cos remains cos only, cos 60 degrees. Now regarding quadrant, we have to see 8 times pi by 2 minus 60 degrees. Look here, 8 times pi by 2, this is 4 2s are 8 times pi by 2 means this is 1 time pi by 2, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. 8 times pi by 2 minus means it comes to this quadrant, first, second, third, fourth. In fourth quadrant cos is positive, so plus only, no need to put minus, into minus sine 30 degrees. Now put values, minus sine 60 is root 3 by 2, cos 30 is root 3 by 2, plus cos 60 is 1 by 2 and sine 30 is 1 by 2, so it is minus 1 by 2. So minus 3 by 4 minus 1 by 4, which is nothing but minus 4 by 4 equal to minus 1. So minus 1 is the answer. Hope you liked the class. See you in the next class. Thank you.